Algebra 1, Common Core, Unit 1, Section 5, Terminology and Writing Expressions. So, ultimately, we're talking about some vocab and terminology here, but what we want to get to the bottom is how to translate things and take words and write them into expressions and stuff like that. But first, we need to clarify a little bit of vocab. What's the difference between an expression, an equation, and an inequality? Well, an expression doesn't have an equal sign. An equation has an equal sign. 2x minus 1 equals 5. That's an equation because it has an equal sign. An inequality has an inequality sign. 2x minus 1 is less than or equal to 5. An expression is just the 2x minus 1 piece. It could have multiple terms, like this expression technically has two terms, a 2x and a negative 1. But there's no equal sign, there's no unequal sign. That's what an expression is. Once you put it equal or unequal, then it changes to an equation, inequality, that type of stuff. A one-term expression is not just a single number. It can have multiple parts, which is a little confusing. That one term could be something like 3xy squared. That's considered a one-term expression because everything's held together through multiplication. Once you have to throw a minus 1 on the end, 3xy squared minus 1. Now it's two terms. Or 3x squared plus 2x minus 5. Now it's three terms. But within each term, there are coefficients, variables, there may be a constant, a base, an exponent, the degree of the expression, stuff like that. So we'll talk about really those all real quick. So coefficients are the number multiplied by a variable. Kind of had a parenthesis there, but don't know, we closed it, forgot to open it. But each term has its own coefficient. The coefficient for the 3x squared term is 3. The coefficient for negative y, we know there's a little hidden 1 there, is negative 1. And 5 would not be considered a coefficient here. Now I know I said each term has a coefficient. I'm going to write it better, negative 1. But 5 doesn't have 5 is not a coefficient because it doesn't have a variable attached to it. It's not being multiplied by a variable. So coefficients are only the numbers being multiplied by variables. And variables are the letters primarily here. So a variable in this one is x is a variable and y is a variable. Something that can change. Like I could substitute different numbers in for x and y. And that will change the value of the expression. A constant, that's what 5 is. 5 is a constant. Because when I substitute something for x, the term 3x squared changes value. When I substitute something in for y, of course, negative y changes value. It could be negative 2, negative 3, negative 5, or positive if I plug in a negative, because it minus a negative. But 5 is 5. 5 is what we call a constant. A number without a variable attached to it is called a constant. Base and exponent go together. Every term and everything within a term could be considered a base and has an exponent. Now, 3x squared here, there's a difference between that and 3x parentheses squared, where the whole thing is being squared. That's not what's happening here. Only x is being squared. So x would be considered a base, and 2 would be exponent. 2 is the exponent. So for x squared, x is the base, 2 is the exponent. But even all this other stuff can be considered bases. Like 3 could be considered a base, and its exponent is 3 to the first. Even this negative y could be thought of to the first. This 5 could be thought of as to the first. So the 5 would be the base, the 1 would be the exponent type of stuff. So everything, every large or regular font thing is a base. The small numbers on the upper right are exponents for them. And you have to be careful. Sometimes people will think that, the 2 is the exponent of 3x, which is not true here because 3x is not in parentheses. It's only the exponent to x. And we discuss exponents, we'll get a lot more detail to that. When we talk about the degree of an expression or degree of an equation, degree of a function, it's just what's the highest exponent. And the highest exponent in this one is 2. So the degree here is 2. All right, so that's some basic vocab stuff. But now let's get into translations. So the 4 operations, addition, subtraction, multiplication, and division. What type of words do we use to represent them? And there's multiple words for each of them. Like this expression here, x plus 2. What I just said, we could say x plus 2. Or we could say the sum of x and 2. Um, those are probably your most common. But then there's one, you could say x added by 2, but you don't really see that, or the addition of x and 2. You don't really see that often. You'll see plus sometimes. You'll see the sum. Sum is an important word for addition. But then you'll also see 2 more than x. 2 more than x means x plus 2. So 2 more than, or this, 2 more than means plus 2. So the term more than is an addition. How about subtraction? Well, you could read this as x minus 2, is I think how most people would say that. Let me just fix that OU. Let me write that again. X minus 2. Or it could be, instead of the sum of, the difference of x and 2. You know, x subtracted by 2, I guess you could see, but not, kind of like x added by 2. You don't see that. But there is one like more than, and it would be 2 less than x. Now, this is an important one. I'm actually going to put a star next to it, the concept of less than. Because sometimes when people see 2 less than x, they think 2 minus. But that's not really what's happening. 2 less than means minus 2. And there's a difference, like we talked about, the difference between x minus y is not the same thing as y minus x. So, 2 more than, that can really be 2 plus, or it can be plus 2, because addition doesn't matter. That's what's called the commutative property. It could go either way. But when it comes to subtraction, order does matter. And so 2 less than is minus 2, and that's really important. All right, multiplication, what would we call this 2x? We would call it maybe 2 times x. Now remember, for multiplication, there's only one addition sign, only one subtraction sign. When it comes to multiplication, that 2x, sometimes you see it as 2 with a little dot is x. And then sometimes, old school, we even use a little x. 2 times x. We would never use the little x if we were multiplying by x, because that's certainly very confusing. But I'm sure people, here's your x for a multiplication symbol. In high school, we tend to use the dot more than anything, but even probably more popular than both of those that you're going to see is parentheses, when something's up against parentheses like that, and there's no plus or minus between things, or just attached to each other. That also means multiplication. So there's a lot of ways to express multiplication, whereas addition, it's really just with a plus sign. So 2 times x, or we could do the product of 2 and x. Let's see, 2 times x, the product of. You notice that there's one like the sum of, the difference of, the product of. And then, there's other ways where it's just, 2 times x, 2 plus x type stuff. Common ones that you'll also see for multiplication are a little more specific, meaning in this particular case, we could say double x, which means 2 times x. Now, it wouldn't apply to this with the 2, but you could see triple x, which would be 3 times x, or half x, which we'll see for, divided by 2x type of thing. So sometimes when it comes to multiplication or division, there are specific ones like double, triple, half, a third, that type of thing. But you'll primarily see times x or the product of, that type of stuff. Division, we do the least amount of translating for. You're not going to see a lot of stuff translated for division. I mean, we could just call this as x divided by 2, or the division of, I guess the other way would say, the quotient of x and 2, but you don't really see those or hear those often, so I'm not even going to bother to write it down. I mean, the one other common thing I think you will see sometimes is half of x, and that's your divided by 2. Again, that's specific to here, or a third of x would divide by 3 type of stuff. So here is your, translation type of stuff. And so you'll see a lot of these words, and you need to be able to write it the proper way. And again, the most common issue is this less than that people mess up. Okay, that's it. We'll practice this more in class. See ya.